So we're going to do the groups that had the large cups first. Now, I know you guys stacked them well beyond this, but we're going to have to pick like some small numbers to make the data fit. And you want to label your X and Y axis. So down here, your independent variable is the number of cups. How tall it is depends on however many cups you did. So this would be cups, and then what would go along this side? Inches. Yeah, height in inches. So cups, just number of cups, height in inches. Do you know how like you can use a quiz or test to help you take the quiz or test? Like I used to do that all the time, and it works in math. Like, do you see how that's actually right here? All right, now I'm just gonna put 1, 2, 3, 4, 5 because these are small numbers. Obviously, you guys stacked them well beyond that, but for the sake of keeping it on the paper, I'm gonna pick little numbers. Okay, so how tall was one large cup? It was 4.5. So without, and like here's what I'm headed with the mathematics behind this, is that if you just measure one cup, you actually don't need to measure the whole stack anymore because you can, like, it's just a pattern, right? Like if one cup is 4.5, what is 2 gonna be? 9, and then 3 would be 13.5. Like you're just gonna keep adding 4.5 each time. So then what would the next be? The 18? And then what is that, 22.5? So what I want you to do is take those points and plot them on here. The 0.5s won't be perfect. It's like good enough. So here's 1, and then 4.5 would be like right there. And then 2, 9, 3, what was that, 13.5? And then 4 is 18. And then we're going to connect it. And I'm not here to grade your art skills, okay, but try to make it as straight as possible. And you can use like the edge of another piece of paper or ruler if you have one. And that's our beautiful little graph. And so then what I did is I took just, you know, an outrageous number that I knew you'd never get to, like 50. If you could stack up 50 cups, what would be the height? So how could we get that? Like, how would we get the height for 50 cups?
You just take the height of 5.
Well, the height wasn't 5, though. It was 4.5. So you would take 4.5 times 50. I'm just typing it in to make sure we don't do it wrong. Good, 225. 225 inches, good. Whenever it's like a real world problem, you want to put units with it. So 225 inches, that would be like through the ceiling. Now we're going to do the exact same thing with the small cups. And again, I know you guys stacked them way higher than this, but let's just do 1, 2, 3, 4, 5, just, you know, for the sake of keeping it on the paper. And again, the goal is you should only really have to measure one cup and then you can figure out what the rest will be. That's the idea. Okay. So a group that had the small cups, you guys had small cups, they were 2.25 each. So again, without measuring any of the others, it's just going to be a pattern where you keep adding 2.25. So how tall would a stack of 2 cups be? 4.5. And then what would the next one be? 6.75. That would just be 9, right? Yeah. And then 11.25. So what I want you to do is take those points, plot them on the grid. Again, it's not going to be like perfect. Just do your best with the decimals. And then we'll connect them and it'll be our graph. Oh, and again, you still want to label. You always want to label your X and Y axis, and it's still the same thing, cups and height in inches. It's just these are small cups. And again, not here to grade your art skills, just, you know, do your best. So we're gonna do the same thing with this one. What would be the height for 50 cups if you could stack up 50? And how would you figure that out? Yeah, take the height, the 2.25 times 50. Did you get it already?
No. It'd be a 0.5, so 142.5.
I love that you guys are using your brains to do that.
Yeah.
112.5.
You get 140. You didn't.
You know what? You were thinking about it and using your brain, and that's really all that I want.
He had the numbers, I had the 0.5.
There, see, so together, come up with it. Don't leave them hanging there. All right, so we're gonna look at these two graphs, and on this slide, I want us to look at some similarities and some differences. So you guys stay on this side so you can write them. I'll leave this up here with this new projector. I don't have a zoom out feature, so this is my zoom out feature. All right, so what are some things that you notice are the same? They're both increasing. Good. Okay, so they're both increasing. Why are they increasing? Like, why does it go up?
Because the cups are growing.
Yeah, like the more
The
cups
number.
you have, like the higher it's gonna be. And I hope we can notice one more thing about both lines. Someone said they both hit 9. That's sort of a coincidence, but they both also hit what?
4.5.
Which means.
There's a very specific point that they both go through that I'm hoping you notice. They both go through 0, 0. They both go through the origin, okay? And that's because, well, actually, let me ask you, why do they go through the origin? Yeah, if you have 0 cups, you don't have any height. Okay, so 0, 0. So they go through, oh, that's actually a calculus thing. We talk about that in calculus. They go through 0, 0. Because if you have no cups, you have no height. And then there was one main difference that I was hoping we can notice. If you come up with others, that's fine, but there's kind of one thing I'm really looking for here. What is a big difference between these two? Yeah, like the angle. Which one is steeper?
The larger
Yeah,
cups.
the first one, right? The taller cups is steeper.
You should just get like books and then stack them up there.
I know. I spent a block in here one day trying to figure out how to make the old projector connect, and it just won't. Like, it's so out of date and they don't make new software for it, so I'm stuck with this one, unfortunately. So there's no point in complaining. Oh, large cups is steeper. Talking, so I can't write and talk at the same time. That should make sense. Why is the line for the large cups steeper?
Because they're going faster.
Yeah, they're growing faster. They're taller cups. So what does the height of the cup represent? And this is what the whole lesson is about. It represents slope. Have you heard that word before? Did you do that in math? Okay,
Enough.
slope, and it is also a rate of change. Put some stars or hearts or unicorns next to that. That's like what the whole lesson is about. Slope, which is a rate of change. It's how quickly or slowly something is growing. Okay, so the larger ones grow faster because they have more height. So then I made just 2 other kind of like real world problems about this. This one's about your cell phone. Your cell phone loses 1.25% of battery power every minute that you use it. Okay, does that make sense? As you use it, battery goes down. I just made it up, okay? Relax. But do you understand that your battery does go down as you use it? It might not be that particular amount. I made that number up, but like it happens, okay? So fill in the missing values and then graph it. Okay, so starting at 0, and let's make sure we label. What would go down here? Hint, it's written on the paper. No.
Time.
Time in
Minutes.
minutes. There we go. That's the minutes that go by. And then what is the y-axis?
Hour.
Yeah, your power percentage. This line is going to be doing what? Like what, as your prediction, we said it's going to go down because the battery power is decreasing, right? So at time 0, we start at 100. That's like you charge your phone overnight and when you wake up, you start at 100. So it's going to start there and go down. Any predictions to when we run out of battery power? Like when, because it's eventually going to get to 0, right? If you don't charge it. Any predictions? Like somewhere over here? like over an hour. All right, let's write an equation. You guys have actually done this before. Do you remember it costs $10 to get into the park and then a certain amount per ride that you ride? It is like, that's where we're headed, but not for a couple of lessons, so just hold on. So we start at what percentage? It starts at 100, and we're gonna subtract how much per minute?
1.25.
Yeah, so it's 1.25. We need a variable with that. It's 1.25x, like per minute, okay? So if 4 minutes go by, you would lose 1.25 per those 4 minutes. I'll pull the calculator up here. So you'd have 1.25 times the 4 minutes. So that's how much you lose. So what's left? 95%. So we're going to put 95% in.
Wait, I was right.
Now let's do the 60. After 60 minutes. So you would lose, what is it? 1.25 for 60 minutes. So that's how much you lose. What's left?
35, or 25.
25%. Now these other ones are a bit harder because they're backwards. Instead of plugging in for X, you're going to plug in for Y. So let me show you this one. You would have 85 in for Y. And what would you do to start solving that? Because I'm going to just type it in the calculator. But what would you do to solve that equation? If you put 85 here, you would minus 100. Guys, just watch. I won't make you write absolutely everything as long as you watch. We'd have our 85. You would subtract 100. And then do what? Like you subtract this 100 over. You would do what with it?
15 times 1.25.
Not times. You would divide by 1.25 negative. So 12. So after 12 minutes, you're down to 85%. We're going to do the exact same thing with the other ones. You would take 70, subtract 100, and then divide by that negative 1.25. So 24 minutes. Oh, and here's 0. Any predictions?
78.
You would subtract 100 and then divide by the negative 1.25.
Oh, first of all,
So 8, isn't that what you guessed in the first place?
an hour and 20 minutes.
Yeah, an hour and 20 minutes.
I guess.
So what I want you to do is plot those on here, and it should make what shape? Like what should you get? A line, yeah, and going down. It should be a decreasing line. So 490, okay, I don't know exactly where 4 is. Like just do your best. It's gonna be like good enough, right? So 1285 would be like right about there. When in doubt, make the points larger. That's what I always do.
No, what? It's less than 10.
Yeah, exactly. Like you can't tell if like how much error there is if you just make the point bigger. So yeah, it's a line with a decreasing slope. And the slope is the negative 1.25. That's what you are losing. Each minute. Now, whenever you're describing slope, you should use the word per. Slope is always something per something else. There should be a per in there. Per is a really weird word, but something per something else. So we're going to write a statement to describe the data using the word per. Go.
Miles per hour.
What?
Miles per hour.
This isn't miles per hour though. Percentage per minute, but let's make it a sentence.
Percentage lost per minute.
We lose how much? You're almost there. We're like so close.
5% every 4 minutes.
Well, let's use this number in there.
What are the
Lose what, 1.25%.
Lose 1.25% per minute. Good. You guys got it. Nice. And that's because 1.25 is your slope. And the reason it's being lost is because it's negative. I made this next one miles per hour. Miles per hour is like the rate of change that everyone is used to because you've all like been in a vehicle. Okay. So you're going on a road trip. You're going to average 60 miles per hour. Look, does that mean you went 60 miles per hour literally the entire time?
No.
No, when I say you averaged 60 miles per hour, that means you sort of went slower sometimes and faster sometimes, and it averaged out to 60. Does this make sense? Okay.
On the highway.
Yeah, if you're on a road trip on the highway.
No, I mean like,
We're pushing like 80 in a minute.
Average is 60.
Yeah. Well, because sometimes you'd be 50 and sometimes you'd be 70, so like it would average.
In our mini, we're pushing like 80 in a minute.
What's that? On average. So like you might get in traffic and slow down a whole lot, and then for a while you might be going 75. So it's gonna average out to 60, is what I'm saying here. Okay. So let's fill in the table. We're gonna start with 0. Hey guys, why does 0, 0 make sense?
Because you don't have any miles.
Because it's the point of nothing.
Yeah, if you haven't left yet, you haven't like gone any distance. Like anyway, you start at 0. That's like you're starting at home. Okay, so after you've gone 1 hour, you have gone 60 miles. Good. So let's write the equation. It would be y equals 60x. Oh, yes. What would go down here?
Hours.
Hours?
Yes.
And then this would be miles. Again, that's going to come from like the problem. You never have to make up units. They're going to be given to you. Like that's provided. So here, let's do the 3, because like when you have the input, that's easy. You're just going to multiply it by 60. Your slope's going to be 60. So 3 times 60 be 180. So after 3 hours, you've gone 180 miles. How would you go backwards?
2.5.
How'd you get that though? Divide by 60. Good.
2 hours plus half an hour.
I'm just going to type it in so everybody can see. Okay. You don't like the decimal? All right, so 2.5 hours. And then for 270, if you divide that by 60, you get 4.5. So go ahead and plot those. It should again be what shape? A line, and it should have a positive slope because you're getting further and further away from home. I didn't stipulate how far we were going, so I guess you just keep going forever until you like run out of gas.
So you think you put an arrow?
Yeah, so I guess you could put an arrow on the end.
That was fun. Oh, yeah, one.
That's true. You wouldn't have anything over here because there are no negative hours. Like this graph starts at 0. So the domain is numbers bigger than 0. I'm glad you're discussing the problem, and that's really cool that you're thinking about it, but can you write it down for me too?
Wouldn't it also be less than x, so how far they're going?
I'm sorry, say again.
Wouldn't it be all numbers like between how far they're going?
Correct. Your domain would be, like if you want, that's so cool you're bringing that up. The domain would be from 0 until, like, I didn't stipulate when you arrive, but like, say I said it's only a 6-hour drive, it would be 0 to 6. And then your range would be 0 to whatever, to 360, I guess would be. So let's write a statement using per. And again, you're gonna have to have a number in there for your slope. But kind of look at what we did on this one. What's our statement with the word per for our slope? Okay, but like we want to turn it into a sentence. Yep, you are driving 60 miles per hour. So this is like the actual like notes part of everything. And I led in with another like real world problem. Slope is a thing that's like super applicable. Slope is literally everywhere. So I love you can like really apply this to anything, okay? Well, almost there. You can apply it to a real world problem super easily. So I like to make them so you can actually understand what we're doing, because then once we get to problems like this where there's no story, those are the boring ones. You know what I'm saying? Or maybe you like those better. All right, so you're at a job, you make, hey, you make $12. Oh, look at what word that is. Per. Did you get a sheet? Hey, did you get a sheet?
Yeah.
Okay, what's your question?
Oh,
Oh, okay. How much do you earn for working 40 hours? How would you get that answer is my first question.
well, I got rid of the 0 on 40 and then I multiplied 12 times
40 would be 48.
48 and you add the 0.
Now, what should I put in front of that 480?
$.
Dollars, cash money. You can put it after, that's fine.
But it's not actually.
But I don't care as long as it's
No, no, no,
there.
no, grammatically, it
Okay,
has to go
well,
first.
that's up to you. All right, how much do you earn for working 35 hours? So again, you're just gonna multiply by 12. That one, well, if you can do that in your head, that's cool. I'm just gonna type it in up here.
362.
420. Wow.
Does it make
Wow.
sense that it's less than this one?
Oh, I'm just simpling it down by dividing it by 100, so I get like, or like, so 1.2 times 3.5.
Oh, I get what you're saying. Does it make sense that this one's less than this one?
Yeah, it does.
Yeah, you worked less. And just for the record, you understand that that's not what you would get, right? Because of taxes, okay? Like you would then have to multiply this by 0.7 and that would be like more roughly what your paycheck would actually be. Hey, I let you sit over there because you requested it, but if I see you not facing forward again, you're gonna be back here in a second. Write this down. Now we're gonna do that backwards. How many hours did you work if this is what you earned? Well, how would you do that? Yeah, instead of multiplying, you're gonna divide. So it'd be 456 divided by 12. I don't remember what it comes out to. 38. Now, what would you put with the 38? It's 38 hours. Hours? You can abbreviate, that's fine.
All you have to do is remove 12,000.
And then for this one, you're gonna take the 384, divide it by 12. Do you have a guess?
32.
32 hours. Estimating is an important skill as well. Like even if you aren't getting the exact answer, well, if 40 hours was 480, well, if I made 384, that should be a little bit less than 40 hours. You know what I mean? Like that's an important skill as well. Okay. So we're going to graph that. Now, where is the line going to start? Even though it's not one of these numbers that we came up, why does it start at 0?
Because you have nothing.
If you work 0 hours, you made $0. And so down here on the x-axis, we're going to put hours. And then the y-axis is dollars, cash money. Dollars depends on hours. This is independent. This is dependent. So you're going to start at 0, 0. And then your slope is 12. Let's see, do we do any of these we can plot on here? 40 hours gave us 480. So for 40, you can put 4. Oh, that's going to go off the grid, isn't it? Well, almost. It like almost fit. Just make the point bigger. And then you can plot the rest of these as well. 35 hours gave us $420. Again, like just close enough. Just make the point bigger. And honestly, that's enough points if you don't want to put any more. Like you can just connect them. You could do a few more if you want. Like for example, if you work 10 hours, because that's an easy one to do in your head. If you work 10 hours, how much money? It would be 120. So like you can plot a few more if you want. But honestly, even if you only have 2 points, that's enough to draw a line. You just connect those 2 points. So at a minimum, you really only need 2 points. And actually, I'll get rid of this part down here because you can't work negative hours. And really, this couldn't go on forever either because, yeah, you can't work. Well, even if you did work 24 hours a day, the week eventually runs out of hours. Like,
And you can get anything out of money, it's just not confident about it.
right, exactly. So this couldn't go on forever. It'd have to stop at some point. But what do you notice?
It's cheap, kind of. Maybe.
That's a lie.
What's it doing?
It's a lot.
It's going up. It's increasing. Well, that would be if instead of paying you, the boss was taking your money, which I would hope wouldn't happen. Is that like when you're at work and you break something and then they take it out of your paycheck?
Yeah.
We'll have like a little dip.
So it could go down actually.
Yeah, like let's hope that doesn't happen.
That'd be a cool
Okay.
graph.
So what is the slope of this line?
12 per hour.
Good. It is $12 per hour. And if you wanted to turn it into a sentence, you could be like, I earn $12 per hour. I just said, what's the slope though? But it should include that word per.
The rate of change.
And this is the rate of change. Perfect. It is the rate at which you do something. which by the way, some of you make it to AP Calculus. This is like the majority of what calculus is about is rates. How quickly things happen or how slowly things happen and speeding up and slowing down. That's like more than half the class is slope.
Yeah, I would take calculus. Required for that.
I'm gonna cut math.
Got it.
But at what year is AP calculus?
All right, so your types of slope. See how this one is going up? That is a positive slope. See how this one's going down? That's negative. I know this is real difficult here, okay?
That's 0.
That's 0. It means not changing.
Can I just call that
Yeet.
stalemate?
Does anyone remember what this one's? It's not called geek. I don't know why that says that there.
Stalemate.
Do we want to play hangman?
Vertical line.
Yeah, let's play.
All right, so vertical is undefined.
I would have gone with undergrad.
And if you just put UND, that's fine. You can abbreviate. That's usually what I put is just UND, but it's undefined. Now I put this on here, come up with a scenario for each of these, because again, it's very applicable to real life stuff. So a scenario that has positive slope, that would be like the cup stacking. So your input would be like number of cups, and the output would be like how tall it is, the height. Like these are all over the place. You can come up with the car one that we did, how many hours you go and then how far you've driven.
The cup's falling.
Yeah, that would be. What was the negative one that we did? Because we did one where it was going down, didn't we? Where'd that go? Here it is. What was our input?
Minute.
Minutes, and the output was like our battery power percentage, because you lose that over time. So input would be minutes, output would be like battery percentage, or like the power of it. You could come up with others. There are plenty of things that decrease in the world as well. Like time goes by and the amount of coffee left in your cup because you're drinking it. You know what I'm saying? Can anyone come up with something that's 0? If not, I wrote down some things. I'm not as good at coming up with the 0 and undefined ones, but I'm gonna just throw that question out to you. Can you come up with an input and output for something that would be like unchanging? It's hard to come up with these ones. Go ahead. You're what? Oh, okay. So as months go by, your grade in a class doesn't change. That could be a good thing. Why would your grade not change? Like if you're just very consistent, you always get the same grades. Or well, but as you brought up, it could be a good thing if you consistently get an A. That could be good. Undefined is particularly difficult. This is what I came up with. You know, like when a rocket shoots up into the sky,
Yeah.
like how that would be undefined. So input would be like a horizontal distance. I'm abbreviating a horizontal distance, and your output would be a vertical distance of a rocket.
So things that cancel each other out.
Yeah, because like a rocket would just go straight up into the air. It doesn't move horizontally at all. It only goes vertically. You can go and do that in physics class. We're gonna just do the mathematics portion of it in here, okay?
The rocket goes like, cause like the broadest space. You have to, like,
Okay, on a certain domain. Again, if you wanna have those conversations, you can walk,
smart and just get this over with.
you can walk right over there
trust me,
and
I
go
have
to a
another smart
physics classroom. We're gonna just do the math part of it, okay?
I'm gonna pull it for anybody else here.
All right. Yeah, that was a personal choice.
It's 30 degrees out.
Wait, it's 30 degrees outside? 38 degrees.
Yes.
Here is your little acronym to help you remember the horizontal and vertical ones. It is HOI-VUX. That's not a word, neither is PEMDAS. It's just like an acronym to help you remember it. So
PEMDAS.
horizontal lines. So the H stands for horizontal lines. Now this is actually like if you want to put a line through it, it means that they have a 0 slope. So horizontal lines have a 0 slope and their equations are y equals something. It'll be y equals a number. I'm just going to make up one really quick here. Give me like a number between 1 and 5, like 3. Okay. So if your equation was y equals 3, it would be a flat line at 3 with a 0 slope. It would be a horizontal line at 3. That's your equation, y equals 3. Like the horizontal and vertical ones are both easy and hard at the same time. It's easy because that's all there is to it, but it's hard because one is one way and one is the other. So, well, no, there wouldn't be an x. It would just be y equals. Go ahead. Yeah, okay, so this would be, V stands for vertical, undefined slope, and X equals. So if you had X equals, give me like a little number, something that'll fit. Well, I made this one 3, so let's do something different. Let's do 2. So it'd be, you'd count to 2 on the X axis and have your vertical line at 2. So again, here's the takeaway. These are easy and hard. There's not much to them, so they're kind of easy, but they're difficult because it's easy to get them backwards. So the HOI-VUX is just an acronym to help you remember that. Horizontal slope or horizontal lines have a 0 slope. That O is like a 0. Their Y equals. Vertical lines are undefined slope. They're X equals. Now this is like, and we're finally getting into like, this is what the problems are going to look like. So if you want to like grab a different color or marker, I'm going to try and highlight this on here. So what you need to do is find 2 points. And do you remember rise over run? Is that something you've heard? So just remember, you have to do the vertical change first, then the horizontal change. It's how much it goes up and then how much it goes over. So there's 2 points bolded on here. They're kind of tough to see though. Can you see this one is kind of bolded and this one's kind of bolded on there? Like, can you see those? It's actually any, but if there are bolded ones on your paper, go for those. Hold on a second. I'm just trying to get everybody else there. Okay. And please draw in the triangle because that's the way they do it on Delta Math, and you're going to have to do that. I'll show you an example on there, but just go ahead and draw in the triangle. And all you're going to do is count how much up and then over. Now, I actually do not like that word over. I want you to say left or right because it does actually make a difference. Okay. So how many little boxes did we go up? So up 7 and then draw a line. And then did we go left or right? We went right. So that's positive 4. It needs to be a fraction because it has to be rise over run. So you can't do a decimal for these, unfortunately. What's that? Oh yeah, do you want to jump straight to number 3? Well, what would 3 be, since you can just kind of glance at it and get that? Well, this would be what? This would be 0, and then which one is undefined? 4 is undefined, and you can just write UND if you want for that one. But okay, let's go back and do the other ones though. That's cool that you saw those. But these were the 2 points that were kind of bolded for number 2. And please just draw in the triangle because you're going to have to do that on Delta Math. And again, when we finish these, I'll pull up Delta Math and I'll show it to you. But they make you draw that in. So how much up or down did we go? It doesn't matter. It will make a difference. If you drew your triangle over here, it doesn't matter. What? So we went down 3. So it's going to be a -3. And then how much over did we go? 9. Now you have to simplify. Go ahead. Yes. Let me finish this one problem. So that will reduce to negative what? -1 over 3. Okay. Try number 5, please. Yes, hold on a second. I'm trying to do multiple things at the same time here though. All right, what did you guys think for 5? And make sure you draw in the little triangle. We went up 5 over 3. Does that reduce? No, so you would just leave it. And then for 6, you go up 2 over 2. What does that reduce to be though? It'd be 1 over 1, which just is 1. So like it would just be 1, up 1 over, up 1, right 1. Try and say left or right because it does actually make a difference. Now 7 just says draw a graph with a slope of -1/3. Does it say where to start? You can start wherever you want. Here's my advice though. Where's the easiest point to start? 0 is where I would suggest it. If you get a choice, and this is not me telling you to be lazy, it is me telling you to be efficient. There's a difference, okay? You get a choice, start at 0. What does this mean we're gonna do for -1/3? Now try not to say down 1,
Right.
3. Good. You're going to go down 1, right 3. Or what's the other thing you could do? Like if I wanted to point over here somewhere, instead of going down, I could go up 1 and then left 3.
Should you draw an arrow over this one?
If you don't, that's fine, but technically it is a line and it'll keep going. I'll put arrows on it. Let me do a quick fraction review. Write this down, okay? It'll only take a second. If you have a negative 1/3, you can write it just with the negative out front. That's fine. You can make the negative be in the numerator, or you can make the negative be in the denominator. Those all mean the same thing. So it's kind of personal preference. It's up to you. Look, this means with the negative in the numerator, down 1, right 3. Do you see what I'm saying? The negative's there. You would go down 1, right 3. Down and then right. This positive one, that would mean up 1, but the negative's there. You would go left 3. Again, they mean the same thing, and the more we practice it, the more you'll get used to it. It doesn't matter where you put the negative, okay? And then we just got a couple more on the back. And again, I'm not here to like grade your art skills, but just try your best to make it be like fairly straight. Now these ones are telling you where to start, so you have to start at that point. So -3, -1. Oh, let's review quadrants. What quadrants would that be in? 3, good. This is 1, 2, 3, 4. So -3, -1 would be right here. And then slope is 2. Now it's really 2/1. So using words like up, down, left, and right, what is that? Like, what are the instructions?
Up to right 1.
Good, up to right 1. So from this point, you're gonna go up to right 1. Miss Cole, how far should we go? I want you to go to the edge of the graph. There's no reason not to. If you can count to 2, you can do this, okay? Just keep going until you get to the edge and you can't go any further. It only takes a few seconds. If you can count to 2, you're gonna be able to do it. And then it'll make it easier to draw in the line. So again, these are telling you where you have to start. 6,5, what quadrant is that in? 1, good. So plot your point 6, 5. Be right here. And the slope is -2/3. So using words like up, down, left, right, where does that, like, what are the instructions telling you to do? Good, down 2, right 3. So from that point, go down 2, right 3, but you can also go the other direction. You could go up 2 and left 3, and just keep going until you've gotten to the edge. Because these aren't huge grids, it's only going to take a second, and then it'll make the line better. You're going to make it. These last two are actually real easy. So 4, 3, what quadrant is that in? 1. So plot 4, 3. And a slope of 0. Is that vertical or horizontal? It's which one? Horizontal. This way. And then last one, -2, 6. What quadrant is that in? 2? And then what kind of a line am I going to draw through it? It's vertical. Oops. Don't stop listening to me. Let me show you delta math really quick. Don't stop listening to me. I want to show this to you. Let me share my screen because I don't want you get to it and then not know what you're doing. Okay, so it's homework 1. You're only going to do 8 of these. Look. You're going to draw a line representing the rise, that's up or down, and then a line representing the run, just like we did a triangle. Now you can pick any 2 points that you want. So you kind of have to find one that lands exactly on like a nice one number. Watch me do this though. You click once to make a point, and then you click a second time to end the segment. Do you see how I did that? I clicked to start and to end, and then I'm going to do the same thing for this way. So I'm going to click right here to start it, right here to end it. So click to start and click to end. Now what is that slope?
-3.
Good, -3. So we went down 3 and then over 4. Cool. Go ahead and get started. You can get it done.